Today in pre-cal we learned about trig applications. The first one is if a homeowner is to construct a ramp of his front door to make a wheelchair accessible, how long is the ramp if the door is 4 feet above the ground level and the angle of elevation is 20 degrees? You want to start by drawing a triangle. All of these problems involve right triangles. That's what we've been talking about. We want to know how long the ramp is. We're going to make that value x, and the angle of elevation is 20 degrees. We got that from right there. And the door is 4 feet above the ground, so we have that measure as well. As long as you have two values, you can always find the third. So this one, the angle is opposite and hypotenuse, which is the relationship of sine. So I'm going to do sine of 20 degrees equals opposite, which is 4 over x. To solve, I'm going to multiply both sides by x. And I'll have x sine 20 equals 4. To get x by itself, I'm going to divide both sides by sine of 20. And when I put that in my calculator, I get that x is equal to 11.7. So the ramp is about 11.7 feet long. The next problem is about a rope in a circus tent. So I have a circus tent pole. There's a rope attached to it that's 80 foot long. So the first part of the problem tells me. The other end of the rope is attached to a stake. That's right here, and that's 60 feet from the base of the pole. And I want to figure out the angle in between. If I look at my angle, I have the adjacent side and the hypotenuse, which is the relationship of cosine. So I have cosine of theta equals 60 over 80. To get the cosine and the theta separated from each other, I have to take the inverse cosine, which looks like this. It has that little -1 exponent. That means inverse. And that can be found by doing second cosine in your calculator, so that's what I'm going to do next. Those will cancel, and the angle of theta should be about 41 degrees. I should have mentioned before now, but it's important that you make sure your calculator is in degree mode. If it's in radians, you're not going to get the correct answer, so double check that by going to mode and then making sure it's on degrees. The third problem says an observer on the 12th floor of a building determines that the angle of depression of the foot of a building across the street is 54.6 degrees. That's this one right here. And the angle of elevation to the top of the same building is 82.3 degrees. If the street is 80 feet wide, find the height of the observed building. We have two triangles, so we're going to follow two processes here. This length is 80, which means this length is also 80. And now I have two different triangles. If I find x that length and y that length and put them together, I'll know how tall the building is. So I'm going to start with the one involving x. I have opposite and adjacent, which is the tangent relationship. So the tangent of 82.3 equals x over 80. To get x by itself, I'm going to multiply both sides by 80. And x will be equal to approximately 591 feet. For the second one, I'm going to do tangent again. And the tangent of 54.6 equals the opposite side, which is y, over the adjacent side, which is 80. Multiply both sides by 80. And y is equal to 112, or about 112. If I add these two together, I know that the building is about 704 feet tall. The last problem is about a surveyor who observes the top of a building, makes a 37.2 degree angle with a road. From another location of 400 feet away, the angle of elevation is 20 degrees. How far is the base of the building from the first observation point? So I want to know this value here, x. First, I'll have to solve this one with y since I have two pieces here and can find the third. To do that, I have opposite over adjacent, so I'm going to do the tangent of 20 degrees equals y over 400. Multiply both sides by 400. And I have that y is equal to 146, so that's this value here. Now I have two pieces on the second triangle, and I can figure that, again, I have opposite over adjacent, tangent of 37.2 equals 146 over x. Multiply both sides by x, and divide by tangent of 37.2. And I will get that x is equal to 192. So the observation point, the first observation point, is about 192 feet away. And that was it for our notes today. The assignment is A15, and that's page 309, numbers 63 to 67. There are 5 problems there. Be sure you draw a picture so that you know what you're looking at.